Dear colleagues, hope you are well. I'm Dr. Francesco Manganu, President of the Digital Dentistry Society International. Like many of you, I'm truly passionate about digital dentistry, and today I'd love to talk to you about an exciting new fully digital workflow in implant prosthodontics. It starts with an intraoral scan and goes all the way to delivering a final restoration, produced with a chairside 3D printer, sometimes even in just a single session. This workflow is based on an intraoral scan with the new highly accurate iTero Lumina scanner from Align Technology. The scan can be sent to the cloud for the dental laboratory, or it can be processed chairside directly through the new iTero design suite. Once the restoration is designed in CAD in just a few minutes, the STL file can be printed using the Dfab printer, a true gem of technology. This desktop printer is capable of producing in just a few minutes crowns and bridges of up to 4 or 5 units in a definitive material with natural shade gradients thanks to its proprietary photoshade technology. After only a few minutes in the polymerization unit and with the appropriate finishing touches, the final hybrid composite restoration containing 42% ceramic is ready to be delivered to the patient. Let me walk you through the workflow by showing you a simple everyday case. It all begins with an intraoral scan using the iTero scanner, even as in this case, immediately after implant placement. The process starts with the opposing arch, then continues with the master model without the scan body, followed by capturing the bite registration. Next, the scan body is screwed in place and its position in space is captured through the intraoral scan. The intraoral scan is then sent via the cloud to the dental laboratory, which in this case designs a customized abutment and a full contour definitive crown for a cement-retained prosthesis. Alternatively, if a screw-retained restoration is preferred, the crown can be designed chairside using the new iTero Design Suite app. The resulting STL file is then ready for printing. For more complex designs, Exocad software is the tool of choice. However, the iTero Design Suite is also an excellent solution, allowing the dentist to design prosthetic restorations in just a few minutes, with results that are clinically very satisfying. At this point, we have our STL file ready for production. In the past, chairside workflows typically relied on milling or grinding the piece. Today, with the development of additive techniques, 3D printing can become the method of choice as it combines speed, ease of use, and unmatched accuracy. First, the STL file must be loaded into the proprietary Nata photoshade software. The software prepares the print completely on its own, in just a few seconds, without requiring any intervention from the operator. The file is positioned in the optimal way, and the printing supports are generated automatically. The only task for the operator is to set the level of the 3 colors, deciding which chromatic characteristics the restoration should have right from the print. Being able to obtain a restoration composed of 3 different shades is a clear aesthetic advantage, providing an excellent foundation for subsequent characterization and finishing. Setting up the Dfab printer is extremely simple and takes only a few seconds. You just open the cover, insert the build platform on top and the cartridge underneath. In this case, we are using an IRIX Max cartridge. It is a hybrid composite material certified for the production of definitive restorations, as it contains 42% ceramic. This printer works with disposable cartridges, which is a huge advantage since it requires no maintenance or cleaning. Once the print is finished, the used cartridge is discarded and a new one can be loaded. Even the base of the build platform is disposable. In just 15 minutes, the restoration has been printed. Before removing it from the build platform and detaching the supports, it undergoes a quick rinse in alcohol to eliminate any residual resin and clean the piece. Next, the restoration needs to be polymerized for a few minutes in the proprietary decure unit supplied together with the Dfab printer. Once the polymerization cycle is complete, the restoration can be characterized as desired, and it is ready for delivery. A recent study of mine showed that hybrid composite restorations produced with the Dfab have extremely high marginal accuracy between 15 and 20 microns, very similar to what can be achieved with a traditional 5-axis laboratory milling machine, and far superior to the results obtained with conventional chairside milling or grinding, which typically reach higher values of around 35-40 microns. All of this comes with a speed that is 5 times faster than traditional chairside milling and at 1/4 of the cost. The restoration can therefore be delivered after proper characterization. In this case, since it was a cemented restoration, delivery was scheduled for a subsequent appointment, during which the customized titanium abutment was screwed onto the implant. This was the appearance of the restoration 6 months after placement, showing good aesthetics and a fair adaptation of the marginal tissues. It is not a milled zirconia crown, but rather a 3D printed crown made of a hybrid material containing 42% ceramic. This material, IRIX Max, is certified for the production of definitive restorations. A recent study from my group reported a 100% survival rate at 2 years after delivery for crowns and up to 3-unit bridges, supported by implants and 3D printed in the hybrid composite material IRIX Max using the Dfab printer. Similarly, prosthetic complications were rare. Dear friends, I hope you enjoyed this innovative workflow and that it may spark your interest. Thank you for your kind attention.